Okay. All right. Welcome, everybody. So my name is Ross Gardler. I work for the Azure Compute team. I work specifically on Azure Container Service as a principal PM. And I'm here with Larry from Verizon. Larry, do you want to introduce yourself?
I'm Larry Rao. I work for Verizon. I'm the Director of Architecture and Infrastructure at Verizon. I work on our internal cloud systems and our IoT solutions.
Excellent. Thanks, Larry. So what we're going to do here is I'm just going to give a short introduction to Azure Container Service, what our general strategy is around Container Service, why we have built it the way we are building it. And then I'm going to hand over to Larry for the majority of the session here. And Larry's going to show what Verizon have been doing on top of Container Service as an example of how this all comes to fruition in production environments and so on. So, you know, the key thing is, and we hear this all the time, the cloud has changed all expectations. We're looking for much more availability. We're looking for much more scalability, both from bursting into the cloud, but also scaling up across workloads that are already in the cloud. And of course, we're looking at significantly increased agility. We've had this whole period of DevOps where we've been talking about developer agility, and Ops has had some significant improvements in agility as well, but we need more. Ops are still not moving as fast as the dev end of that spectrum. And one of the things that has made it possible to provide more agility, more scale, more availability is this evolution towards containerization. So quick question. How many people in the audience here use containers today in either a dev test or a production environment? Okay, the number goes up every time I ask a question, but we're still only at about 25%, even when we include dev test in there. And so we're on this transition right now. We're understanding how to make this transition to this next phase of computing. And the slide we have here is kind of looking at the transitions that we've had over time, way back in the mainframe days, way over there on the left in the I think it's listed as 1960s on here. We had this big computer that ran the software and these thin clients that provided interfaces to it. And then we moved on into the idea of client server, where we had smaller things running elsewhere. They weren't running on these big mainframes, but we still had the server. But the clients were now getting much thicker, and there was much more of this moving out to the client machines. And then we move on into the web area, where it was kind of somewhere in between the two. We're now kind of going back to thin clients, especially when you look at the mobile environment. They're much thinner than what we had in the client-server era. But we're also breaking the applications down into smaller pieces. So the server components for these are actually much more focused and they're not doing everything. They're doing a significant function for the web-based applications that we're building. And then we move forward to today, and we're in the middle of this progression to what is called on here the era of the cloud. Some people would want to talk about it as containerization. Other people would want to talk about it as microservices. And all these words, they're not the same, but they're all part of the same movement. And that is the ability for us to build software solutions that are breaking those big monolithic server-side applications down into even smaller parts, even smaller components that increase the agility, increase availability, and so on. But it's also happening on the client side as well. We're increasingly building applications like this on the client side. So why are we doing this? Most of you are probably already fairly comfortable with this concept. When you're building large monolithic applications, you're kind of limited to how often you can upgrade, how often you can deploy these things, how you scale them. Because every time you want to scale a new instance, you have to create a new machine on which to run these, or at least a new virtual machine on which to run these. And you can only deploy the complete application as one. Well, it's not very scalable, it's not very agile, it's not very efficient. So as we move to smaller services, and I like to use the term smaller services because it encompasses all of that microservices, containerization, and all of those things. It's about breaking the application to smaller services. And you decide how small you want to go. Do you want to go all the way to microservices, or do you want to just start with taking your monolith, putting it inside of a container, and then breaking away the piece that needs to scale independently? And what you end up with is something that looks a little like this. You have a number of machines, and you take each of these smaller services or containers, and you deploy them to the machine that is best suited to run it, the one that has the capacity, the one that is able to provide the best support for that particular application. Maybe it has certain kind of, maybe it has a GPU, for example, so it needs to run on a machine with a GPU. And this gives you much more flexibility, much more agility, because you can now deploy and scale each of these pieces independently. And this is very, very powerful. It brings huge advantages and huge flexibility. I actually cut this slide last night, but we've just had a bit of a do with the slides, and it has come back in. I'll quickly talk about it. But you have lots of options as you move into the cloud. And so you can rehost. You can just pick it up, lift it, and shift it into the cloud. Containerization gives you a vehicle by which you can do that. You can wrap your application inside of a container, and that gives you a level of portability, a level of control that you didn't previously have, because now your container contains all of the runtime requirements and everything that you need for that lift and shift environment. You don't have to be going towards a fully microservices-based architecture. You can take your monolith, wrap it in a container, and run it. The next phase along is refactor. Doing that rehosting doesn't really give you all the benefits. It gives you some of the benefits, but not all the benefits that we can get from containers. And so the next logical step is to refactor that application. It's to break off individual pieces that need to scale independently or need their own independent release cycle or whatever reason. And a concrete example that I personally find easy to imagine like this is if you imagine an e-commerce system. And you have these orders coming in. Well, you want to scale the parts of the system that receive orders to cope with however many orders you've got coming in at that point in time. And then you want to scale it back down again. But there's other parts of an e-commerce system, if you think of the entirety of the system, such as the piece of the system that manages stock control in the warehouse. Well, it's only so fast that your robots can move, or your human being in a forklift can move around that warehouse and take things off the shelves and so on. So you might be receiving thousands of orders a second because you just did a TV advert, but actually you're still only processing tens or hundreds of orders a second. Well, that's a pretty fast forklift, but you know, these things don't need to scale at the same time. And so refactoring to allow that gives you significant advantages just by breaking off a tiny piece of functionality from the side and delivering that as a separate container. Redesign, this is the same kind of approach, but this is saying, well, actually now if we're going to be moving into the cloud, we can take advantage of software as a service and PaaS environments, so we don't have to worry about our storage. Rebuild is to just start from scratch, take advantage from the beginning. Greenfield, we can really not bring all the baggage of the monolith and start from scratch from day one. And replace is if you're managing, for example, your own database systems on-prem right now, well, if you are moving into the cloud, it's actually much more efficient and much more cost-effective to use a SaaS service for something like that. Why should your operations people be worrying about deploying and managing a database replicated across the world when we can do it for you? And so containers allow you to pick where on this spectrum you want to be. Everywhere from just lift and shift the monolith with no code changes, all the way through to complete rewrites, taking advantage of PaaS and SaaS environments and everything in between. So why do we do this? Well, there's loads of surveys out there that tell you containers are important, but most of them are conducted by somebody who have something to sell you. And can we trust those? This particular one comes from Cornell University, and as far as I'm aware, other than education, Cornell University is not trying to sell you container solutions. And what they found is, you know, it is consistent with what you see from the less independent surveys that are out there. So they saw 62% reduction of mean time to resolution. That's, I've identified a problem, I've fixed a problem. 62% reduction. 10 times cost reduction in maintenance as a result. In terms of scale, 41% of respondents to this survey were running hybrid workloads, public and private cloud environments, and able to burst into the cloud or even move complete workloads into the cloud where it is sensible to do so for that particular workload. They actually used the word eliminate works on my machine. We haven't really eliminated it. We're certainly much better than we were first time we said we'd solved it, and the second, and the third, and the fourth, and the fifth, and I don't know where we are. But it works really well. Docker gives us a level of portability that we've not seen before. There are a few caveats. You do need to be a little careful. But for the most part, we have eliminated works on my machine to the point that people are actually reporting, yes, we've eliminated that problem. And then agility, on average across these organizations, 13 times more software releases. Right? The more you release, the faster you're moving. And 65% reduction in developer onboarding. And this one is often missed, but we all have turnover in our developer ecosystem. The faster you bring those people up to speed, the faster you are using their time, their brains, their input onto the project productively. So containers are really important from a strategic and a directional point of view. So what's Microsoft doing in the container space? Our goal is any container running anywhere you want it to run. Okay? It's that portability thing. So any OS, Linux versus Windows. I work for the Azure Compute team. My job is to grow Linux cores on Azure faster than Windows cores. Now, there are people in Microsoft who are trying to grow Windows cores faster than Linux, as you would probably expect. But the key thing is we are investing significantly in making sure we can run those Linux workloads right there alongside the Windows workloads. And in a container space, that becomes very, very easy because of the work we're doing in the container ecosystem with Windows Server containers and so on. You can use the same tooling to manage both kinds of container. And it should become, eventually, completely transparent to the operations team. It's just a workload that's going to run somewhere. The somewhere is important. Containers give you that level of portability, and we recognize that we have to support that level of portability. If you want to run in your own data center and burst to the cloud, that's what we're going to enable. If you want to have a multi-cloud strategy, that's what we're going to enable. If you want to do dev locally but production in the cloud, that's what we're going to enable. You tell us what you need in the hybrid, and we will enable it. And the reason we do that is quite simply because we want happy customers, because happy customers keep coming back for more things. It's not about getting you to run everything on Azure. It's about getting you to run the things you want to run on Azure, and us providing the tooling so that you can run that stuff in Azure and run stuff elsewhere. And so you'll see a strategy across Microsoft where things like OMS, for example, Operations Management Suite, which will monitor containers, will run and monitor containers in Azure, but it will also run them in other clouds or on-prem or wherever you want. Any app. I've already dwelled on this. We're not just talking about microservices when we talk about containers. We're talking about all the benefits of portability and agility and so on. So that monolith wrapped in a container, yep, we're going to support that. We're going to make it work for you. Equally, we'll help you with the microservices pieces as well. We'll even go so far as to provide you with PaaS layers that will make it really, really easy to do that. But if you want to run those inside of containers, again, we'll make that possible. And of course, any language, because in a container environment, all of the dependencies come inside of the container. So at least theoretically, and for the large part in practice, we don't have to do anything special. As long as the tooling is available, you can run that workload in a container on Azure. And I'm from Azure Container Service, which is what this slide is about, but you'll see that across all of Azure. You can put a container into app services, for example. You can put containers into other services elsewhere. So what do we do in Azure Container Service? Well, we provide the three most popular orchestrators, Kubernetes, DCOS, and Docker. And our focus is making sure that we just deploy those workloads for you, those orchestrators for you, and then we get out the way. And you use whatever tooling you want to manage the workloads on that, because we're just exposing the APIs defined by these open source projects. And so any tooling that emerges in the ecosystem, you can use to manage these solutions. What if you want something a little more opinionated? What if you want something that is, I don't want to have to think about the tooling, or I haven't made my tooling decisions? Well, naturally, Microsoft is providing tooling, and you saw yesterday some demos of Visual Studio, where Visual Studio has first-class support for containerizing workloads and deploying them into Service Fabric, App Services, Azure Container Services, wherever you need to run these things. So bring your own tooling, or we'll provide you with tooling optimized for the environment. The key thing is that we're focusing on exposing just the standard APIs so that you can bring your own tooling. And this is winning for us. No other cloud is doing this. They all have their various opinions. And this is winning for us. We're winning customers left, right, and center. There's a few logos on there that we're allowed to share. We have Verizon on stage to talk more about why their logo is up there. This flexibility to use the tooling of choice is very, very powerful. So we're going to talk a little bit more about DCOS as one of those orchestrators. The Verizon uses DCOS. The reason we're choosing, we partnered with DCOS, or rather we are using the open source DCOS, is because it's Apache Mesos based. Apache Mesos is a scheduler that's been around for a very long time. It grew up in the data space. It runs things like Spark and Cassandra and Kafka and workloads like that. And this particular scheduler has been proven at very significant scales in industry. So you will see people like Twitter and people like Airbnb and Apple and so on are using Apache Mesos. It's been proven at significant scales. It also brings, DCOS brings a set of tooling on top of Mesos that gives you a nice UI and things like that. You'll see a little bit of that shortly. Because it comes from the data space, Mesos is capable of orchestrating using many different frameworks on top, one of which is called Marathon, which deploys Docker containers for you. But you can also run Spark, which I have traditional, in quotes, containerized workloads. What Spark does is it runs as a container. It's just not running as a Docker container. It's using the same kernel primitives to containerize those workloads. And Mesos can run those different types of workloads right next to each other. The other orchestrators, you can still do that, but you have to run them as Docker containers, and that brings advantages and disadvantages. Depending on your workload, it's either a good thing or a bad thing. And then you also have a thing called the universe. We won't dwell on that. The universe gives you options for new frameworks, new things that you can run in cluster, like Spark, Kafka, Cassandra, and so on. So at this point, I'm going to hand over to Larry. And Larry is going to talk, oh, I'm not. Sorry, I was looking at the wrong screen. I have a, sorry.
It's all right.
Can you contain your excitement a little longer?
I'll wait a little longer.
Okay. I did want to highlight this point. And so what you see here is the infrastructure piece at the bottom for Azure Container Service is Azure. Okay? And we believe we're building the best cloud and it's the most available, et cetera, et cetera. You've heard that elsewhere. The green piece is what we're providing inside of ACS today. A slight caveat, managed services is not available today. It's something we're working on, so that's things like upgrade of the clusters, et cetera. Today, we don't actually do a fully managed service. I call it IaaS Plus. We stand up the infrastructure, and we put the orchestrator and so on top. The next layer up, the orange piece, is about your application management. This is where you're using tools, the ones that we have up here. Vamp is a tiny little startup from England. I'm English, so always call out for the English people. They are building an application layer where you just say, I want to deploy this, and it allows you to do things like A/B deployments and migrate workloads backwards and forwards. DDC stands for Docker Data Center, so that's Docker's fully commercial, fully enterprise-supported solution built on top of the open source Docker. MapR focuses on data workloads and really has a very good experience for working with data in containerized environments. DCOS EE is the enterprise edition of DCOS and so on. And so we have partners in that layer, some of them are named there, who are bringing choices for application management tooling on there. And increasingly, we are providing additional services on top of that as well for those who don't want choice, they just want to get going and get running. And then finally, the customers piece at the top, we don't reach into that space. We're not a PaaS at this point. We're simply running your containers, and how you build your application is up to you. So at this point, I will hand over to Larry. And Larry's going to talk more about how Verizon are using ACS. So.
All right, great. Thanks, Russ.
Thank you.
Yeah, so a little introduction. So I work, obviously, at Verizon. I work on do the Director of Architecture and Infrastructure. My job is I'll explain how we got to containers and all this, and I look at different aspects of Internet of Things, IoT space, and that led me into doing platforms. And we'll talk through our story about how we came to containers. We do this on our internal data centers, and then I'll talk a little bit about why we're standing up on stage here at an Azure talk, and why we started looking at how to use Azure. And I'll do a little demo at the end just to provide a little bit of proof that we did something. So how we got here was basically the challenge my team had was address Internet of Things at Verizon. And at Verizon, we run everything at scale. We have large, over 110 million subscribers. And if you imagine all those people start adding devices to the network, there's a large amount of devices that are expected to come onto our network and use our services, consume services on our network. So the challenge is how do we accommodate all those devices? So we started looking at how we built our services. And obviously, we went around the microservices route, and Ross talked a little bit about this, and it's just a sound architecture, and we break things up into small components, and small components that can do their job well, and then we can individually update all those components. And then we started looking about, what's the best way to deploy this? And I saw some challenges in our infrastructure and how we deploy software within Verizon, so we started looking at what we can do to make that better, because we anticipate a world where we want to move quick, we want to add new changes to our software, we want to just shorten that cycle, which is good for our customers. And so, of course, we said, containers, and this is over a couple years ago, we started looking at containers because they're nice little boxes and we can package them up and ship them around the world. So with containers, we decided early on that's how we wanted, that was the unit of distribution of our software. And then you start looking at, what are we going to do with all these containers? And you realize we're going to have many containers that we have to deal with. And if I look at our infrastructure internally, the way we deployed infrastructure in Verizon, it looks like this. So we have a bunch of silos, and they're actually old silos, because you go and you figure out how much hardware you need, you go schedule time with the data centers, you figure out space and power needs, you line up behind everyone else who's figuring out space and power needs, and you finagle and you negotiate, because it's a resource that's very prime in our data centers throughout the country and throughout the world. And if you have to keep doing that every time you introduce new solutions, or when you want to do major expansion, it becomes a problem. So we looked at doing cluster computing. So this makes sense. You take your containers, you take your set of hardware, you look at the set of hardware as a very consistent platform to run on, and you throw your containers at it. And then you realize we actually have many clusters. We're going to have many clusters around different data centers around the world, ultimately. And so you start looking at, how do I manage all those containers? And that led us to Apache Mesos, and then DCOS from Mesosphere. And we use Linux, obviously, under the covers. I listed a couple of the technologies. We use a lot more stuff, but these are some of the technologies. Cassandra databases. We implement our stuff in Go. Again, languages aren't important. A lot of our solution uses multiple languages. We use Spark. We use Kafka. All these things had to run in our infrastructure. Therefore, they had to be in containers, and therefore we had to orchestrate all these containers. And that's what we looked at, Apache Mesos. And so again, this is back to the whole theme. It's I can containerize everything. An orchestrator is really what lets you evenly and optimally distribute those containers across your infrastructure. So now truly, I have a platform underneath that can be managed. I have an orchestrator that can move my containers around. I have a nice vehicle for packaging up my applications into microservices, and I let the orchestrator figure out where they run. Ross touched on a thing about container size, and it isn't, you can literally containerize anything, and it's not hard. You can also end up with huge containers. My recommendation, what we stress in ours, we keep the containers relatively small. We keep the microservices relatively small because it allows the orchestrator to find a spot to run your application. And we look at horizontal scale. So you don't try to max out the machine and the hardware because you're going to have a variety of hardware types ultimately over time, depending as you add machines and as you take machines out of service, you're going to have a set of hardware that doesn't look unique. But the orchestrator and the containers, all you got to do is find a spot. I always use like there's a bunch of little holes around the data center, and you got to just find a spot for that container to fit. The less resources that container demands, the more opportunities the orchestrator has to find a spot to let it run. We also can run many of them, so you build all your apps to horizontally scale, and that's how you handle load in our systems. So some of the benefits we saw was improved application management and efficient use of resources. So this is everything from how developers package, how the DevOps teams deploy, how it's managed. All these things become easy. You can make changes quickly. You can deploy those easily. I don't have to worry about what packages are on the host machine. Everything I need in the application is packaged in the container. So if you have 5 different Java runtime versions, awesome. It doesn't matter. It's in the container. You use different libraries, great. It's in the container. So these things allow you some flexibility in the development and the deployment cycle. Speed and elasticity. This allows us to scale. So it's very now we can show you if you guys look at Mesos, it's really easy to scale things, and we have tools in place to monitor our applications. Look when applications are under load, and you can ask the orchestrator, can you just bump me up a few? And you'll find containers run. And we've done presentations publicly in the past where we've run lots of containers. And this works in reality as well. The other thing the orchestrator gives you is I don't have to reserve resources. This is hard for people like developers to understand because you're used to going, you know what, I'm going to run on this machine and I'm going to size everything exactly for that machine. And what you're allowing here is you're allowing the software to find the places to run and make more efficient use of your hardware underneath. And finally, there's an isolation of the software from hardware. When you're looking at cluster computing, one of the advantages is hardware fails. It's a fact of life. Hardware will fail. And what happens is the orchestrator sees that, it notes the failure, and it takes your container and it launches it somewhere else in the system. If you built your applications correctly, you don't notice the glitch. And your systems will be a little more fault tolerant, even in the case of faulting hardware. And that allows you to even relook at how you buy your hardware, how you service your hardware. Because what I always envision is we have very strict and very short SLAs at Verizon. So when something fails in hardware, there's like a guy has to like descend out of the ceiling and replace that hardware right away, and you have to pay for that. So if you can let that hardware fail, and I always say we replace our hard drives on Tuesday, whatever Tuesday it is, and you can come in after the fact and say, you know what, I'll come in and start replacing the failed disk drives. And literally we come in and pull a sled out of the rack and just replace the sled and send the sled back. And during that time period, the containers, it's like little bugs. They scatter around and find another place to run. And that allows you to replace your hardware. So again, you can streamline all your resources. So then we start looking at, I talked a lot about why we did it on our internal cloud, and then we can look at public cloud as well. And some of if you don't have, Verizon has a large amount of infrastructure. We know how to manage that. We have a lot of data centers literally around the world. So from our perspective, there's benefits to being in your internal data center. If you're not in that position and you're looking for, you don't have to build out a data center. What you're trying to do is a little different from us. But I think you can leverage both of those. So internally, we can leverage the fact that we own our resources. And there's some advantages there in our purchasing power. Again, as the larger you are, the more you have internal resources, the the better it is for you to manage those resources. And we have the technical talent and the know-how, and we have the experience. So it makes sense that we can leverage our internal data centers. But cloud allows us to look at different things. Cloud allows us potentially to go and look at other locales around the world where maybe we don't have a data center. And depending on the solution you're trying to deliver, there's reasons why you may need to be in a local area. And so that gives us some reason why we might want to look at public clouds and why we might want to stand on stage here and talk about some of the work we did with Microsoft. And so one thing that became apparent was the use of something like a container orchestrator like Mesosphere's DCOS, which we adopted and used. The fact that it runs on top of a public cloud, now you have that extra layer of abstraction that divorces you. So now I can look at the public cloud and I can look at my internal architecture, my internal infrastructure, and go, you know what, from a software perspective, from my application perspective, I don't see a lot of changes. And that's a good thing. That allows us to move quickly. So again, our applications are packaged for easily deployment, and the containers are orchestrated by Mesos. And just like in our physical hardware, where the hardware might differ across the data center, now you just have a different infrastructure underneath our orchestrator. And that's what the public cloud can provide. So this allows us to move. We run Mesosphere's DCOS on bare metal. You see Mesos DCOS on Azure's Container Service. We have some tooling that manages the underlying infrastructure to suit our needs from a monitoring perspective or from a resource usage perspective. And our experience with the Azure Container Service, we've done a couple different efforts to move different non-trivial parts of our different applications onto Azure Cloud just to see how it works. And these applications range from applications that are a heavy use of storage, and internally we use an object store, and it was very easy to retarget those applications to Azure's object store system. We obviously have stateless applications. Obviously, Azure already had DCOS available. And so all these things made it easy for us to look. And the bottom line is, the bottom line on my slide is it just works. And it literally, we had very little change to some of our applications. Now, obviously, the bigger, you're gonna have to do some changes. The changes usually were around the configuration. We had to look at networking differently. We control our networking in our internal data centers. That's one of the great things about we can control that infrastructure. Networking is kind of important to us. And so that's one aspect. But as we move to different services that can be consumed or put into the public cloud, that's just one area to look at. So with all that, just to show some aspects of what we did, I did put a little demonstration together. And what I did is I took one of our IoT solutions, and we kind of separated out something that was I thought was kind of interesting. One interesting from a deployment standpoint on Azure, one a little bit to show different technologies that can be used inside containers, one to show how easy it would be for us to move. And literally, we put this demonstration together. I took some of our product level code. We had a project in flight, and we worked with Microsoft to set up some systems on Azure, and we moved over. And I'm going to do a demo in a second, but just to walk through what you're kind of going to see, and to give you some ideas, we have a lot of different parts here. One is you'll see a web portal will come into our portal servers. Everything's events being thrown through Kafka to different parts of our backend system. And this IoT solution that we're going to kind of look at a little part is about, well, if my customers end up with a lot of data from their IoT devices in our system, how can I let them use that data? And if that data is really large, what technologies can we deploy to allow those customers to use that data? And then how can I control a little bit that environment that's using it so we don't have things just run away in our data center from a resource usage perspective? We have to be able to understand how those resources are being used. So what we effectively do is we have what I labeled here on the top right, where Spark is DPE is our data processing engine. And this is a very generic infrastructure. at its heart, we leverage Spark, and we'll show some demonstration of that. We also leverage the fact that we can spin off containers that do additional processing on their own, so that you can package up a bit of processing power, if you will, and that can be dispatched to answer a question you might have about your data. And these data processing engines can reach out to different data sets. So they'll reach out to our IoT data set. There might be different projects and solutions. So again, it's a typical big data type set of technologies that I can go and look at a disparate set of data sets, run queries across all of them. So that if you had data spread around different solutions, you can come and look at it from a different perspective and go access all that data. So we needed some compute to do that. And that's what we ended up using Spark inside Mesos, in containers, obviously. On the bottom, we have what we call runtime executives, and I'll demonstrate those as well. This allows us to actually take snippets of code that an end user can provide and put it in an environment, wrap it in a container, and deploy that container inside our cluster and execute that. And what that little snippet of code can do is go and look at your data, access your data, mutate your data, create new data, send notifications out. So again, it gives you the ability, a flexible way to interpret your data, leveraging the infrastructure we have, leveraging containers, leveraging the orchestrator, so leveraging our whole platform. And we wrap this all up into a little bit of a live demo. And what you see is a couple of our developers took this, and with really very little change. And I'll switch over. Yeah, it says demo.
Yeah.
So let's see if that switches.
It's timed out on your back.
Let's see if I can get in. Verizon security protecting me. All right, so.
Do you want to make the text a bit bigger on that?
Oh, no, that's okay. This isn't important. We'll go over here. That's just to show, like, it makes it look cool that there's a command prompt running, so it gives me some credibility. Right? I don't know what it is, but. This actually highlights one of the significant changes we had to make to do this demonstration. You'll notice the title is called undisclosed because we had a project name, his internal project name. Our attorney said you can't use internal project names publicly, so I had to choose a different name, but then I thought that name would be internal. So we ended up with it's undisclosed. And we actually literally had to make some changes just to go through and say it's undisclosed. So one of the engineers spent a large amount of time, not really. So this portal, there's a concept out there called notebooks, and there's a Apache Zeppelin. We don't use Apache Zeppelin, but that's the concept. And this gives you an ability to come into the system and actually do some interesting things, so you can create your own notebooks. And what you might want to do is come and say, if I wanted to do some calculations on numbers, you look at this distribution, you run all these things. So you'll see these things executed, and I'll show you a little bit about some of the code. So what's happening right now is when I execute, there's code inside these blocks that get executed. And you can edit this live here, rerun it, and what happens is that code gets packaged up, sent to the server, wrapped in a container in a runtime environment that gives a protected environment. So you can't do things like put infinite loops and things like that. I'm sure all you guys would do that instantly if I let you. I did that. The team brought this up, and they said, look, you can spin up containers. But the containers all ran on a single node. So I'm like, oh, okay, cool. I know how many cores our nodes have, so I requested more containers than the cores, and they all kind of just waited. And then, of course, a couple days later, there was a check in there to limit the number of containers. But this is kind of cool that you can come in and you can do some more. This one's good. It comes up with a number. That's awesome. This one's a little more exciting. You'll see some queries coming on in here. So again, and this is all Lua scripting, but what I referred to as a runtime executive is language neutral. We did a version with R, but the intent is you can write in different languages. And you can come back and you can come to notebooks. I can create new notebooks and add, you can add this. And, oops. And so we have a little markup, and then you can add, if I wanted to add Lua, I can come in here and add some Lua code. I have a bunch written already, so you can come, see this. Just so you can believe me, let's rerun this guy. So you saw that the title changed, so we'll just come in here. So when I execute this, it's actually going to go out to the server. Oops. And actually, if you saw this little thing move, is because it was actually in transit. Of course, it happened really quick. So anyway, this allows you to run different queries in the system. Ultimately, this allows you to share notebooks, so a collaborative tool, so different organizations can share. The whole concept of notebooks is around kind of like a data scientist notebook. So that's kind of what this application does. If I take a look now, and if I come over, if you're familiar with DCOS, you'll see that we have a bunch of stuff running here. Don't look at the name. I'm not allowed to tell you that name.
I saw undisclosed. It said undisclosed.
So these are all the tasks actually running, all the applications running in Marathon at the time. If we come and look at nodes, you can see all the nodes and the activity that's happening at the time. So these are all servicing. Every time I ran a query that did one of the graphs, it was actually executing. A lot of those graphs were executing a Spark job, actually. So that little bit of query code got packaged up and got transmitted to a Spark cluster running. So if we actually kind of go in and look at some of our, actually let me go here. This is the Mesos UI, if you're not familiar. This is kind of like the stock one. If I come in here, you'll see this compute, DCOS compute is actually running Spark. So you'll see the Spark running inside. You have to kind of believe me, but it actually is running Spark. And these are Marathon and Metronome running. You can come here and look at all the agents that we have. And this is just to do a little demo. We put a little database up here, copied a bunch of data. A lot of the data that you saw over here is actually from one of our IoT solutions. It's simulated data that we use to test some of these. So there's quite a bit of data, so we can come and say, if I want to look at battery life on certain devices, I can come and run different queries on this device, on the database rather, and that gets sent back into a processing engine. So what I want you to get out of this is, one is we literally changed very little bits of code. You see it's not a simple application. I stand by the line that we had, is it just works. We got this running. We had to make a few little configuration changes. We didn't have to recode anything. And we were able to move from our internal DCOS cluster onto an Azure cluster without much issues. And it's not really a trivial application. So these are all the tasks that are running right now. And this is small. We set up a fairly, I don't know, what did we do, like 30, I think, nodes in Azure. Inside my test cluster inside is about, we have 2 clusters that come out to about almost 40 racks of equipment. And we have data centers, our production data centers. We have more than a few 100,000 cores running in our production system. And this is just a sample of some of the applications. We literally run in our test cluster, because app developers are bringing containers up and down. We're running millions of containers over a couple week periods. And we can look at our Mesos and see how many tasks have been running. So again, the move to containers allows you a lot of flexibility in your development. It allows you to package, allows you to manage your applications better. Ultimately, it allowed us to move easily from running inside our own infrastructure and running this on top of something like an Azure platform. And I think that's about it, unless you guys have questions about any of this. I think I was
So
gonna hand
yeah, I
off
just
to
want to
you.
close over, and if anybody does have any questions, there's a couple of mics dotted around. Feel free to move up to those, and we'll take a couple of questions as we move forward. I just want to close off saying a couple of things. First of all, thank you very much.
Thanks.
So there's a couple of things that stood out to me there. First of all, it just works. I mean, that's our goal, but our goal is better. For Azure Container Service, the goal is it just works, but better. Okay, so the idea is, yes, you can run this stuff anywhere that DCOS will run. We want you to run it in Azure. That's how we make our money. And the way we let you to run it in Azure is to make it run better, because we're not doing anything proprietary in our space here. And that statement of it just works should be true, and is true as far as we're aware, for each of the three orchestrators that we have: Kubernetes, Docker, and DCOS. Increasingly, we are moving more and more towards the managed service for each one of those things. So right now, you said, we had to get in there, we built the cluster out, etc. We make that very easy through a resource provider, but there's some configuration tweaks and hand-holding and so on going on. And as we move more and more to a managed service, we'll be making less and less work in those configuration changes, etc. And in addition, we'll be providing more and more features like those that you need for managing the higher level applications. So we looked at individual tasks running and things like that. And so we're investing significantly on providing higher level application management features as well. But the whole industry around containers is still very early. There's still an awful lot of innovation going on in that space. And so one of the things that I didn't mention earlier on with ACS Engine is, with ACS, with the introduction, is that we have this concept of ACS Engine. ACS Engine is actually the code that we use to run the resource provider inside of Azure. It's a piece of Go code. You can get it from GitHub. You can run this piece of Go code with the configuration parameters for your cluster, and it spits out a very large ARM template, an Azure Resource Manager template. And that template describes how the Azure infrastructure gets configured and how the software gets deployed on top of that. And this is really useful for people who are building on top of Azure Container Service, as Verizon are doing, because it means that Verizon can work directly with us about what the future of Azure Container Service looks like. What additional features do we need to expose? What are those things that you need to tweak in order to make this specific kind of runtime work? And so it's an open source project. It's out there on GitHub. If you have engineers who want to get down into the code, the configuration, they want to optimize every single piece, we're there and we're doing our development work in that repository. If you would prefer to have the fully managed solution, well, that's what you'll get through the portal, through the CLI, etc. And then you, just like Verizon, will be able to take your workloads and it'll just work inside of that environment. So I recommend that you actually try this out. If my statements prove not to be true, I want to know why, and we'll look at fixing it. We didn't switch it over. aka.ms/ACS will take you to the landing page for that. We have somebody waiting to ask a question. Fire away.
Hi there. I think I'm not in the minority in this room. I'm one of the ones that has not used a container in production yet, and we're investigating what container orchestration service to use. And one thing that I think I would get a lot of value out of, and perhaps most everybody else in the room, would be what guidance can you give us for how to select the right container orchestration service to use?
Do you want to say why you selected DCOS again, and then I'll talk about the other two?
Yeah, I'll tell you how we landed on DCOS. And again, you got to consider we started looking at this a couple years ago. And as Ross mentioned, Mesos is tried in the industry, so battle tested. So if you look at companies like Twitter is the most obvious, Apple, these are all companies that run it at larger scale. I think I run large clusters. They run enormous clusters. And so when we looked at it, we're like, look, this is cutting edge technology, but at least it's been run through the paces. And I think there's aspects that are unique about Mesos from a resource. They split the resource and scheduling between it so that you can actually have different schedulers. I think they're a little more advanced in the types of workloads they run on the platform. So I think that's some of the benefits of Mesos.
Yeah, and so That's a very good answer for why DCOS is useful, and some examples, and really that highlights the key question. We can talk in generalities, but in truth, what we need to do is look at the specifics of the application. Now, this is going to change in time, and it's changing very rapidly. The orchestration piece, eventually, they'll all do essentially the same thing. I mean, what they do is they tell a container where to run. And as long as it runs, and it runs well, and it matches the constraints that we provide, we don't really care exactly how it works. I certainly have no idea how my Windows laptop or my Linux compute team, I don't know how the orchestration works, and eventually I'm not going to care. Today we do talk about this and which one which prefers. So DCOS has its advantages that Larry just talked about. Docker is the user experience inside of Docker is just amazing. You know, Docker build, Docker run, Docker compose, all these things are very, very easy to get your head around. And we see a lot of people adopting Docker because of that user experience, how easy they have made it to run container workloads. Kubernetes, that's not focusing on the packaging format. It's not focusing on how you build these containers. It's focusing on how you orchestrate. So there's a piece in the Docker ecosystem called Swarm, which does your orchestration, and Kubernetes is kind of a replacement for the Swarm piece. Kubernetes, because it just focuses on that piece, is able to move at a faster pace at some point. Now, this is changing in time as the Docker ecosystem solidifies at the image format and so on. But for cloud-native workloads, so web APIs and REST APIs and so on, Kubernetes has some significant advantages in that space. You know, the way it handles, for example, load balancing is just beautiful. It's really easy. Inside of the other orchestrators, you have to go in and you have to open an Azure load balancer if you open up a new public port. In Kubernetes, it just happens. And there are other things like that. So each of them has their advantages today, and you need to evaluate your workload as to which one is the best solution for you.
That's actually a good point. Some are more opinionated sort of idea of how to do certain activities, and then some are a little more lenient, I'll say, or allow you to have some flexibility. So that's another key area that you want to look at. Then you want to look at something like, you look at Apache Mesos as a orchestrator, you look at DCOS as an orchestrator plus a set of capabilities around it that you also have to start thinking about. So there's a lot of things when you get into the networking and even the container management, the package management, there's things that you know, like a DCOS provides on top of Mesos. So you want to look at that environment.
Yeah, so it's not an easy answer, but if you do want us to tell you, we will. You know, we'll look at the workload and we'll say, oh, you need to be using this orchestrator. And over time, I predict that we won't need to have this conversation. I think that there will be either obvious choices or fewer choices.
Okay, thank you.
So any more questions? There's one over here. We have a few more minutes left, so we'll probably be able to take 2 more questions. If you do want to come up to the microphones, go ahead.
So how the containers are helping in terms of moving databases?
I'm sorry, I can't quite hear you. Do you want to?
How the containers are helping moving databases to it? Because scalability is something different.
Sorry, did you say databases?
Yeah, like SQL
Yeah.
Server.
Okay, well, you mentioned storage. Do you want to talk about your experiences, and then I'll talk in generality?
Yeah, storage is something you do want to pay attention to. We run what's become known, at the time we started it didn't have a clever name, but it's become known as hyper-converged clusters, which basically means you're running your stateless and your stateful applications. We do run different databases. I mentioned Cassandra, that's a primary one. The challenge with any of the databases inside the cluster is to think about how they find each other, how the peers and how the clients find each other. So that gets back into some of the discovery and the networking. And then the other part is how do they access their underlying storage? So do they have to, there's a couple strategies. We've used different virtual block storage systems so that they will present to an application what looks like a block drive in a file system, but it's actually spread across several nodes underneath. And that gives you flexibility in a cluster. You can park it to a machine, what we call pinning. So you end up, the disadvantage of pinning is, the advantage is you get an actual physical hard drive. The disadvantage is you're parked on that node, And so if that node fails for any reason, you've lost, say, your Cassandra node, and then it has to migrate somewhere else, and that's a little chore. So we've developed some tools and strategies for how to manage all this. How do I discover, my peers discover each other? How do my clients discover each other? How do I map it onto the underlying storage? That's something that there's a couple different strategies depending on in our case, we obviously use Mesos. There's a couple different strategies you can use, but it is something you need to think about.
Yeah. Yeah, I would agree. This is one of the areas where DCOS and Apache Mesos actually have an advantage because they grew up in the data space. But when you're running things like Cassandra, you're not actually running those as Docker containers. You're running them as containers, but they're using the Linux level C groups and namespaces and so on to give you the isolation of containers. And consequently, you have more flexibility with what you can do, and you have to do the kinds of tricks that you were talking about.
Right.
Again, point in time. As the Docker ecosystem matures, more and more solutions around storage will become hardened and become viable. Today, it is complex, and this is one of the areas where you have to do additional work. If you're starting from a greenfield site, our recommendation right now is let something else worry about the storage. Your containers themselves should be stateless. So they're writing their state out to a queue externally, or a table externally, or to Cassandra externally. And that way, you're not constrained by the current limitations in the container ecosystem. But there's some fantastic work going on in this space, and it's only a matter of time before the answer becomes, oh, it just works. You just set this configuration flag, and off you go.
Yeah,
We're not there yet.
In the database, in the storage space, it's all going to, I think there's going to be a lot of movement in that space to make sure everything does run well on these clusters, because there's advantages. So if you find different solutions, this is in general, not just storage, if you find solutions that have to have, say hard-coded IP addresses, or in general, if your application or the thing you're trying to put in the container makes any assumption about the actual physical hardware underneath, you're probably going to have some things to think about when you run inside a cluster, because you want to sort of have that separation.
Excellent. So any more questions? We have just time for one more, if there is one more.
Come on, we need one more question.
Thank you for using up our last couple of minutes.
We get rated bad if you don't ask all the questions.
So when do you see making the fork driving towards essentially containers versus serverless deployments?
I'm not, so did you describe it as a fork? Did you say fork?
Well, so in other words, obviously there are, given having to run in a local data center, if I'm purely cloud, there are some options for going serverless that make sense, and I can totally avoid the container, but can you kind of draw out the line on when I should be driving more serverless than container, if I have those choices?
Yeah, honestly, I think that's an open question. And I'll go first to give you time to think this time. I think that's an open question. In an ideal environment, when we get to a fully managed container service, you'll no longer be worrying about servers. So in the future, containers are serverless as well. So it really depends on how we think of serverless. If we really mean you don't think about the server on which it runs, and then containers are going in that space as well anyway. We're already there with something like app service. You deploy a container to app service. But then serverless often means something more like functions. And that's more of an application model and how you design your applications. And like all application models and architectural designs, each approach has advantages in different use cases. And I think serverless, if you're not careful with something like functions, if you don't really think carefully about how you're weaving these things together, it becomes really hard to figure out why your system doesn't work. You start to see emergent behaviors and side effects and so on. Containers are more like the traditional development of applications. The code that you're running inside of there is self-contained, and it provides not just a function, but a service, which is a larger unit of abstraction. And so for me personally, with a background in object-oriented programming, I can get my head around that a lot easier. Okay. Over time, as we get better at the idea of true serverless and functions and so on, maybe that will no longer become true, but it's going to take a long time. If we look at are containers going to replace virtual machines, to look at a similar kind of thing, maybe, eventually, but certainly not in the foreseeable future, because virtual machines provide very significant advantages in very significant use cases. So I'm dodging the question because I don't have the answer. I think it's much more complex than the question implies, but maybe you have a different view.
Yeah, I think it depends on what you're trying to do, and then you have to look at one advantage you get is not only do you not manage the infrastructure, the hardware, and you're not managing virtual machines, now you're not even managing containers. It just feels nice that you can just write a little bit of code. What I actually demoed is akin to that. Now we built it in containers, but our usage in mind is kind of like a business analyst that can write small snippets of code, and then it just runs. So we kind of built that function. So it's not an either or. It's going to depend on what you're trying to solve, I believe. And then what resources do you have at your disposal? I have all the physical resources and data centers and all that stuff, so the answer is a little different for me.
Okay. All right, thank you very much. That's time up. Do remember to do your evaluation forms. I'm required to put the last slide up, but you don't have to read it.